deriving the slope and the intercept of the ordinary least squares equation. So we actually have beta 0, which is the intercept, and beta 1, which is the slope. So we derive them to actually minimize the sum of squared errors and prediction errors. So it's very important before we start to note that yi is the known value and y cap I is the predicted value. So we'll be using the basic linear regression model, which is y is equal to beta 0 plus beta 1 x I plus the error term, which in some cases would use mu, right? So this is our known equation, which would be very significant in the next sections. So its sigma is into yi minus y cap I all squared is equal to sigma into yi minus beta 0 minus beta 1 xi all squared, right? So we derive specifically based on beta 0 and beta 1, and then would equate them to 0, right? So I've actually divided this into two parts, which is our step 1 and step 2, which in step 1 we have our first derivative, and then we have our second derivative. In step 2 we call these derivatives the minimum conditions, and then we call the whole process the first condition order, right? So let's get to step 1. So in step 1 you would have your derivative of beta 1 multiplying the sigma into yi minus beta 0 minus beta 1 xi all squared, right? So we'd rearrange the equation just to make it proper, and then it would be equal to sigma multiplied the derivative of beta 0 into yi minus beta 0 minus beta 1 xi all squared, right? So you would want to get rid of the square, which is 2. Since we are using calculus in this case, we would then use the power rule. So it would then be equal to sigma into 2 into yi minus beta 0 minus beta 1 x1, and then you would be multiplying the whole equation by -1. So we know that since beta 0 is the intercept and it has a base which is -1, so since we are deriving and we are using calculus, we would then use the chain rule, and then would get rid of the -1 by timesing the whole equation by -1, right? So we would have our end equation as -2 sigma into yi minus beta 0 minus beta 1 xi is equal to 0 of the minimum condition, right? So that's our first condition and our first derivative. So we'll move to step 2. In step 2 we would do actually the same thing, except for that in step 3 you would have your whole equation being multiplied by xi. This is actually happening because when you are doing deriving specifically based in beta 1, you know that beta 1 is the parameter of x1 or the coefficient of x1. So you would use the chain rule and then take out the xi, which would be negative, and then you would multiply the whole equation, giving you a derivative which is -2 into sigma yi minus beta 0 minus beta 1 xi into xi, which is equal to 0 of the minimum condition, right? So we'd call this the first order condition. So I've compiled this just for us to first get a better understanding before we move to the second section, right? So we'll be solving, we'll be actually finding the exact values of beta 0 and beta 1. So it's important to note that x bar is equal to 1 over n times your sigma xi, which can be also be written as your sigma xi is equal to n x bar, right? So our second thing that we must note is that sigma yi is equal to n y bar, right? And then our third thing to note is that x into xi minus x bar all squared is equal to sigma x squared I minus 2xi x bar plus x bar squared, right? So just multiply the whole thing by opening brackets, and then you multiply by your sigma, and then you get your equation 2, and then you substitute sigma xi by nx bar, and then you get your equation 3, and then you would want to take the sums, collect the same sums, and then you would be having your final equation, which is sigma x squared I minus n x bar squared, right? So which would be equal to your sigma xi minus x bar all squared, right? So we'll be actually moving to the derivatives of beta 1 and beta 0, finding the exact values. So the derivative of beta 0, you would be having your sigma, which is into yi minus beta 0 minus beta 1 x1, and then it would be equaling to 0, right? So you would want to times the whole thing by sigma. In other words, you would be wanting to open or get rid of the brackets, right? So you would be having sigma yi minus sigma beta 0 minus sigma beta 1 xi is equal to 0, right? So we would be substituting those specific formulas I showed you, and then you would be having ny bar minus n beta 0. We'll substitute n in beta 0 since it's the sample size and beta 0 is the y-intercept. So it would be negative beta 0 minus beta 1 nx bar, which would be equal to 0, right? So you would solve, and then you would have now your y bar, and then equaling to beta 0 minus nx bar, which is equal to 0, right? So you would want to make your beta 0 the sum of the formula, and then you would be having beta 0 is equal to y bar minus beta 1 x bar, right? So let's go to the derivative of beta 1. So when we're deriving, we had the equation, which is negative 2 sigma into y I minus beta 0 minus beta 1 x1 into xi, which is equal to 0, right? So you would want to actually multiply the whole thing by your sigma, and then you would be ending up on your equation 3, which is sigma xi yi minus beta 0 xi minus beta 1 x squared I, which is equal to 0. You would be actually doing your substitutions there, and then you would be having your sigma xi yi minus beta 0 sigma xi minus beta 1 sigma x squared I, right, which is equal to 0, right? So you would substitute in your sigma xi with your equations that we were deriving on our previous sections, and then would be having sigma xi yi minus all into y bar minus beta 1 x bar all into n x bar minus beta 1 sigma x squared I, right, which is equal to 0, right? And then you would be just wanting to open your brackets, and then you just see the whole thing, and then you would then want to make you want to equate that side starting from beta 1 to the left, to the right hand side of the equation, and then you would be having your sigma into xi minus x bar into yi minus y bar, which is equal to beta 1 sigma xi minus x bar all squared, right? So you would want to make your beta the subject of the formula, and then you would have beta 1 is equal to sigma xi minus x bar into yi minus y bar divided by your sigma xi minus your x bar squared, right? So you will just be substituting what I have shown you and the rest of the equations, and then you would be getting your exact value. So this is how you get